Well, Heidi-ho, neighborinos. We are going to finish Unit 4, Lesson 5. This is Part 2 video. We have about 3 problems, something around that ballpark. We are going to finish them, and we will be done with Unit 4, Lesson 5. So why don't we get started? Talking about fruit flies. The number of fruit flies in an experimental population after T hours is given by, okay, I don't know why they use Q, but Q of T equals 20e to the 0.03 T. Now this just looks to me just like APERT. Okay, wow, my board is stroking out already. So let's try that again. APERT. There it is. All right. Now, that shows growth. This is obviously continuously growing, okay, just like some of the financial equations we've done. Okay, that shows continual growth, all right? So the question for A, or the statement, is find the initial number of fruit flies in the population. Well, this is my initial investment or initial number. So if I look at my equation, that would be this number right here, okay? So 20 is the initial number of fruit flies. We'll say 20 flies. All right, 20 flies. There we go. Good to go. B, how large is the population of fruit flies after 72 hours? All right, well, keep in mind our equation is 20e to the 0.03 T. This gives us our population, which they're calling Q of T. All right, and time in hours. T is time in hours. So when I look down here, I say to myself, right here, 72 hours. This is T. So in my calculator, I'm going to put 20e to the 0.03 times 72 because that is my time. And I am going to let the calculator do all the work. Okay? 20. Yep, the 2 needs to be there. 20 e 0.03 times 72. All right, and let's hit enter. And that is 173.4. All right, so I'm going to do this. It is 173.4. Was that a 3? I'm losing my mind. It was. All right, well, keep this in mind when it comes to population. You can add another, let's reference humans for right now. Let's say the population on a certain village is 100. Okay, let's say a woman is pregnant and she's going to give birth next week. She's 90% of the way through pregnancy. I cannot count that baby in the population until it is born. I don't round up because she is 90% of the way through her pregnancy. I wait till that kid is born. As soon as that kid is born, then it's 101. All right, so for me, there are 173 flies, okay? I will not have any more, even if this was like 0.8. Until this fruit fly is hatched, it won't count in the population, all right? So I would say that's 173 flies, and really pay attention to the question. They might tell you to round to a certain decimal or whole number, which would be fine. But in general, we don't count a living creature until it is born, hatched, whatever. Okay, so no partials. C, when will there be 29 fruit flies? Use a calculator to approximate this answer. All right, so we still know that our population, or our Q, hey, that might stand for quantity, equals 20 e to the 0.03 times time. Now this 29 they give us, that is actually the population. So when will the population be 29? Now, until we start solving things using log and natural log, okay, we would have to use log or natural log. We're not there yet. So how can I do this in a calculator? I'm going to put this in Y1. I'm going to put this in Y2, and I'm going to graph them. and where they intersect is going to be my answer. Okay, so remember the x-axis or the independent variable is our t in our equation. So whatever x value where these two lines or graphs intersect is going to be the t value. Let me show you. I go to y equals. I clear this out. I say 29 for y1. Then I say 20 e to the 0.03 x, okay? So x is really our t, our time. And that's what they want to know. When? When will there be 29 fruit flies? So if I graph this, I might not see my graph right now, okay? Obviously, this window, if I go to my window, I have it 5 by 5. Let's do this. Let's go to zoom. Let's go to a standard 10 by 10, which is what most of your calculators should have. I'm not going to see any graph yet. How come? This one is 29. That is not in between 10 and negative 10. I need to go to at least 29. This starts, okay, isn't that our initial population? That starts at 20. So in order to see the beginning of my population, I need to be at 20. In order to see this, I need to be at 29. So I'm going to go and I'm going to adjust this graph. I want to go at least as high as 29. Now, let me try something else here. There's a little secret or a little shortcut I use. If I hit zoom, if you scroll down, there's something that says fit. It doesn't always work, and I'm curious if it'll work now. There it is, zoom fit. That is option 0. And when you select that option, it tries to put in all the characteristics that you need. Meaning, if I was graphing a parabola and I went to zoom fit, it would try and put in both x-intercepts or zeros and the vertex, okay, because those are important characteristics. Now, if I'm graphing a line and a curve, like I am in this case, and I hit zoom fit, I'm hoping, I don't know, but I'm hoping it'll have at least the intersection of those 2 points. Let's try and figure it out. Enter. Okay, it's changing. Oh, there's our line, and there's our 20e to the 0.3t. It looks like we're just missing, okay, our intersection. Zoom fit gives me a good spot to start. Here's 29, y equals 29, and here's our second graph, which is this function right here. They're going to intersect just off to the right. So I need to go a little bit higher on my y-axis, and I want to go a little bit further to the right. So I'm going to look at my window. I want to go a little bit further to the right, so I'm going to double that. I'm going to call that 20 on the x-axis, okay? And I want to go a little bit higher. So let me, I don't know, I can kind of double this if I want. That's maybe 50. Let's pick a number and see what happens. There's 29. Oh, and there's my graph right there. Look at it go. Look at it go. Beautiful. This point, wherever it intersects on the x-axis, remember, x is our t. That's going to be the time. So I go to second, calc, and I want the intersection. Choice 5. Boom. I bring my little spider dude as close to the intersection as I can, and I hit enter 3 times. Bang, bang, bang. That intersects at 12.38. 5, 4, 5, 2. We don't need all those letters. And those aren't letters, those are numbers. The X and Y are the letters. Okay, so that is approximately at X. Approximate this answer. So if that's time in hours, so I say X is equivalent to 12.38, I could say about 12 hours. Okay, if they want an approximation and we're in a lab, we could say about 12 hours. Okay, so yeah, we don't want that. So that would be 12 hours. It doesn't tell us the round. That's legit. I mean, if you want to say 12 and a half hours, anything that's kind of close or in the ballpark or reasonable. It did not tell us where to round. It just said to approximate. We could have said 12.4 hours. I would have accepted it. You know what we're doing. Let's move forward. Example 1, okay, exponential regressions. These are cool. We've done regressions before. This should be no different than what we did before for quadratic regressions. I don't know if we did linear regressions or not, but we definitely did quartic or cubic regressions. I know for a fact quadratic regressions. Same thing, okay? The best temperature to brew coffee is between 195 degrees and 205 degrees, okay? Coffee is cool enough to drink at 185 degrees. Man, all this talk of coffee. Mm. Oh, it's so good. Okay? Coffee is cool enough to drink when it's 185 degrees. All right? So when they brew something and it's around 205 degrees, that's when we're like, ah, hot. I burned my tongue. You want it to be closer to 185 degrees to drink. Okay? I've seen that temperature fluctuate. I've seen like 140 degrees or 150 degrees, but for the sake of our problem, 185 degrees. The table below shows temperature readings from a sample cup of coffee. That's this table right here. And how long does it take for a cup of coffee to cool enough to drink? All right, so that means how long we need the time does it take for our coffee to be cool enough to drink? So how long does it take before it hits our 185 degrees? All right, use an exponential model rounded to the nearest thousandth. So if we're going to do we are going to do a regression, and instead of picking quadratic regression, the only difference is we're going to pick exponential regression, okay? So the first thing we need to do is we need to put this into our calculator. There's our calculator. I'm going to move it over here. Boom. And if you remember, in order to begin quadratic regressions, we need to enter in this data from this table. I go to Stat, Edit. See, choice 1 is Edit right there. Okay, and time is going to be my L1 list, and temperature is going to be my L2. So I go from 0, 5, and this goes up by 10 all the way to this goes up by 5s all the way up to 30. So 10, 15, 20, 25, 30. Beautiful. My temperatures starts off at 203 degrees when it's brewed, right at the start. After 5 minutes, it cools down to 177. Bam. Then it goes to 153. Okay, 137. All right, 121. 111. Haha. And 104. All right, I'm going to take a look at these numbers. They look good. I haven't missed any because I know sometimes when I hit this calculator, it misses a digit. They all look good. Perfect. So I enter in my data. Next thing is I need to get my equation right. So now I hit Stat, Calculate. I got to move over to Calculate. And now I pick the regression. We are used to doing quadratic regressions, okay? But we want exponential. How do I know? It tells me in the problem. I want an exponential model. So I'm going to scroll down until I see exponential regression. There it is. 0. And now you don't have to do this. I always like to do this to be safe. I put Y1 here so it puts it in the graph. I hit vars. I move over to Y vars. And I hit enter, enter. And now I calculate this bad boy. Here is my regression. Now, they want this rounded to what? To the nearest thousandths. Okay, use a model, round it to the nearest thousandths. Okay, so here's my model. I'm going to round it to the nearest thousandths. Thousandths is 3 decimal places. That'll be 7, and it will stay a 7 because the number after it is 2. And this 7 will round up to an 8 because the number after it is 5 or bigger. So my A value goes into the A value here. Y equals 196.657. Yep, that's okay. Times B 0.978 raised to the x. That means exponent, okay? Raised to the x. That is my equation right there. All right? They want to know when this will be 185 degrees. 185. Okay? Because isn't L2 our output? It's our y. L1 is our input. That's like our x. This is our y. Okay, so equals 196.657 times 0.978 to the x. Again, this is the same thing we had with the flies. We haven't used log yet to solve these things. Okay, so I'm going to put this into y1, and I'm going to put this into y2. All right, now let's just make an educated guess right now. Where on our table here, okay, where on our table here in temperature does 185 degrees fall? Okay, they want to know when's it going to be 185. Well, I hope you know 185 should fall right between this 203. Yeah, wow. Right between the 203 and 177. So my time should fall between 0 and 5. If I get a time that's 18, like right here, 185 does not fall here. Okay, so logically, my answer should be between 0 and 5. All right? Let's do this. Let's do this, children. Let's go to y equals, and you'll see, if I go to y equals, my regression got put in there for me. And that's nice, but I need to use my rounded one. So let's clear this out. First, I put 185 in. Now I have 196.657 times 0.978 raised to the x. Okay? Now, if I just do my standard window, okay, if I go zoom and I go 10 by 10, which is standard, that's choice 6, I am not going to see this. Again, 185 is way out of the window, and so is 196 where I'm starting. Okay? I don't see anything. Let's adjust my window. I know I need to start above 196. Okay? Actually, I should start on my y-axis at 203, and I want to include 185. So I'm going to have a window. Let's change my window here. Window. Let's go to my y's. I'm going to start, let's call it at 220. And I'm going to end, and let's call it 170. Okay, and I will do that increment by tens. My y is by tens. My x's, we just said it has to be between 0 and 5, doesn't it? My answer should be between 0 and 5 on my time. So I'm going to call this 0. I'm going to call this 5 by 1. So let's graph that. Okay, there's 185, and there's my drop. There's my coffee cooling. We can visually see it cooling as time goes by. That's awesome. So I need to find out what time does that happen. Time is my x variable here, right? So right here where they intersect, I need to find that x value. Second, trace, because that gives me my calculate. And I want to calculate the intersection. Choice 5. We just did this. And my little bug dude is kind of close, so I hit enter 3 times. 1, 2, 3. 2.746. All right, so my answer is when x is approximately 2.74, we'll make that a 7 minutes. Why am I leaving this in thousandths? Because it wanted me to do this in thousandths, so I'm leaving my answer in thousandths. So roughly 3 minutes, okay? That's not bad. A lot of work, but a lot of it was done in the calculator. And I'm explaining this, so we're going a little bit slower. If I was doing this with a calculator, reading it myself, and I had to do it, and I was comfortable with what I was doing, this would probably take a minute and a half tops. Okay? Let's try another one. Example 2. The table below shows the number of new stores in a coffee shop chain that opened during the years 1986 through 1994. Wow, that had to be quite the boom because now there's coffee stores everywhere. All right, and there's our table. Okay, our years are 1986 on the left and the number of stores on the right. Okay, using x equals 1 to represent 1986. So right off the bat, this is my x value. 1986 is 1. Okay, and y to represent the number of new stores. This is my y value. Write an exponential regression. Again, I'm going to have to do this in the calculator. for these data, round all values to the nearest thousandths. That's 3 decimal places. All right, if 86 is 1, 87 is 1 after that. Okay, 88, you're going to see these all go up by 1, okay? 5, 6, 7, 8, 9, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 of them. So in my L1 column are my X's. In my L2 column are my Y's, right? So let's call up the calculator again. Let's clear this second plus 7, 1, 2. That clears everything. And let's do the process again. If you want to pause it, do it yourself, go nuts. If you don't have a calculator, but you have an Android phone, you can actually get this Wabbit. You see right here, it says Wabbit right there. See that bang, bang, that little Wabbit there thing? Wabbit EMU is actually available on Android or Google Play for Android phones. I actually have a YouTube video, how to install Wabbit on your Android device, and that walks you right through it. It's pretty cool. And you will have this exact same picture here. You can change the calculator color. I have it gray here. On my phone, I have it like this light red. It looks really sweet. It's nice. So if I don't have a calculator like this, and it is exactly the TI-84 Plus, this one right here. It's the one you use in your classrooms. All right. So if you don't have one at home, but anywhere you go with your Android phone, you got one. All right. So let's do this. Stat, edit, and I'm going to go 1 through 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 9. Okay, 9 elements. I move to the side here. Starts at 1. 14, 27, 48, 80. Wow, that was a big jump. 110. Yep, see the 8. 80. All right, 110. 153. Bam. 261. Wow, that was another huge jump. 403. Yikes. And 681 because Americans are just addicted to coffee. Right? All that looks good. All that looks good. Now I want my regression. Stat. Calc. I got to move over to calc. Okay? And if I remember right, I believe it was choice 0 was an exponential regression. And there it is. I could have selected 0 or scrolled down to 0 and hit enter. And let's just calculate this bad boy. Bam, there it is. Yahtzee, here we go. Boom, love it. So let's write this equation and round everything to the nearest thousandths. This 5 will move up to a 6 because the number after it is 9 or bigger. This 6 will stay a 6 because the number after it is smaller than 5. So my A value, oh, highlighters, A goes right here. My B value, that goes right here. All right, so let's write this. We've got Y equals A, which is 10.596, times my B value, 1.586, for the X. They don't want us to calculate anything. They just want us to get the regression. Pretty simple. Nice. We are all done. Let me check. Oh, look, nothingness. All right, well, we're done. I think we have a quiz coming up. Who knows? Anyways, I hope to see you back because it's always fun hanging out with you. I hope to see you back for Unit 4, Lesson 6. Have a great day and stay mathematical, my friends. Stay mathematical.